Okay, here are the answers for the homework. Number 3 should look like that. And identify what P is. Then that way you can get the focus and directrix. The focus is always inside the parabola. Directrix is behind it. And the orientation obviously is horizontal because y is being squared. So if x is not squared, it's actually horizontal. If y is not squared, it's vertical, if that helps. For number 10, it should look like that. And notice I'm still plotting points. I don't want to be haphazard. We're trying to just draw like you're a 2 or 3-year-old. You want to draw it nice and neat if you can. So I chose y was -1 for number 10. That way x is 6 or -6. So I'm choosing values for x and y that are integers. I mean, you could be random if you want to, like say, oh, what if x is 1 and figure out what y is? This makes things more complicated. But you're starting to see that when the focus is longer or further away from the vertex, this is getting wider. If it's closer, it gets narrower, just so you know. 11 looks like this. P is 3, opening up. And you have those values for the extra points. And for 17, you get that. Divide by 3. Your p-value is -2, actually. So you're going to the left. You can still say p is 2, I suppose. If you want to say that, go ahead. But negative implies you're going left if it's a horizontal orientation. Of course, down if it's a vertical orientation. Yeah, very good.
Do you care if we write like P? Should we say P is 2? P is negative?
I don't care. I don't care. Doesn't matter to me. Just make sure you have the right coordinates for the focus and the right equation for the directrix. That's what matters to me. Looks good.
As like example, y equals to 1 over 4.
You can if you want, sure. I mean, I'm just going to do it this way, but you can totally do that. That's fine. I just prefer to avoid fractions if I could. But yeah, some people do say like instead of 4px equals y squared, they'll say x equals 1 over 4p times y squared. Some people do that. For 23 and 24, those are the errors. Looking at the question itself, yeah, y squared equals 6x. That should be a horizontal orientation. So not up. And then this one here should be reversed. Excuse me. It's still horizontal orientation, but it's going to the left. For 29, there is your focus. So I would kind of just do a quick sketch, even though you're not asked to sketch. It's sometimes good to visualize it. And you see, oh, okay, it's going down. Okay, so I have to go 4py equals x squared, so and p is -4. Or for 33, you get that. We're cool so far. 39, that's the directrix. So you have those varieties. So that should be okay, hopefully. Remember, the directrix always goes behind the parabola. When I say behind, like the parabola opens away from it. We're good there. Cool. I don't think I assigned the word problem, right? Okay, good. We're going to talk about that today, so that's fine. First of all, how long does homework take? Oh, good. Oh, good. Okay. Because I assigned so many problems. Okay. Okay, that means I gotta give you more problems then. What was that? Sure. Okay. Got it. Yeah, circles should be pretty straightforward again. Here we go. You got your center is 0, 0 every time. The radius is just the square root of the other side. But of course, divide by 4, like in the case number 2, or move everything to one side. So, I mean, move all the variables to one side and get a constant on the other side. Whether or not I simplify the radius, I don't really care. It's up to you. Writing equations, that should be pretty straightforward as well. Yeah, that's not that hard. If you have a point in the circle, use Pythagorean theorem to get the distance between the center and the point in the circle. It should be 5 and 13 for 7 and 8 respectively. Excuse me. Yep, we're good. Okay, cool. And then for 9, 10, the whole tangent business shouldn't be too bad. Remember the slope of the radius. Find that first and do the negative reciprocal or inverse reciprocal to get the slope of the tangent line. And I do point slope form afterwards to write the equation of line. Obviously, I didn't do that here because back in the day I just did do y equals mx plus b. But you should embrace point slope form. Kingston, go ahead. 10 is right here.
Yeah.
The slope is negative 9/5 of the radius. So the slope of the tangent line is 5/9.
Oh, do you change the radius? Isn't the question it's
Mhm.
x plus y squared equals 17? So that's what confusing.
Yeah, don't worry about the radius so much.
Okay.
You just have to find the slope between the center and the point that you're on, that you're doing a tangent line of,
Okay.
or the point of tangency, if that makes sense. Yeah. I didn't sign 11 or 12, right? Okay, cool. All right, so all is okay. Okay, good. So that's just more like just kind of drill and kill a little bit, just getting you accustomed to this stuff. All right, that's easy. All right, so let's move on to the lesson. We're going to talk about ellipses today. The first thing I want to do is just to remind you of what it's supposed to look like when you cut a cone. So if you cut a double nap cone, you could cut it really anywhere, top or bottom cone. But if you cut it at a slant, the cross section would be an oval. So like that second image from the left. So that's why that's another conic section. So that's what we're going to talk about today. So let's start with page 7. I know we didn't do all the notes from 1 through 6, page 1 through 6, but that's okay. We'll come back and do some other ones later. Let's just kind of just sort of jump into it. So let's look at number 1. Actually, Kingston, can you read number 1?
Do I read the equation too?
Yeah, whole thing. Yeah.
Okay, the equation, the quantity of x minus 4 squared over 36 plus the quantity y minus 3 squared over 36 equals 1 is the equation of a circle, but it's not in standard form of a circle. Rewrite the equation so that it is in the standard form of a circle. Where's the center and what is its radius?
Okay, so multiply both sides by 36. Hopefully that's pretty obvious. The center should be 4, 3. And the radius should be 6. Okay. All's good. Okay. All's good. All right. But what if the denominators are different, right? So first off, let's look at number 2 again. Sorry. Number 2 re-examines number 1. Notice subtle difference. That 36 and 36. What happened from here to here? From the x minus 4 over 6 squared plus y minus 3 over 6. These are the same, but how do I know they're the same? Go over.
You put like, you added parentheses.
Exactly. I extended the parentheses. So if I do that, then I have to then make that a 6 to guarantee the same denominator. Right, correct. Okay. So what we're noticing is that it's kind of like a stretch in a way. It's kind of weird, but it's kind of a stretch. Because it does impact the radius. So what if I switch the first denominator from 6 to 2? All of a sudden, it's not going to be circular in nature. It's going to be a bit oblong. That makes sense, like a football in a way. If I go to Desmos to show you what happens, Desmos will be a great way to explore. Then I'm actually going to show you the derivation. The derivation is pretty wicked for ellipse. I'll never expect you guys to on the test. That'd be a little much. But if I do what was again x? Okay. Let me close these other windows or files. Actually, I'll leave that open. X minus 4 over 2 raised to the second power plus y minus 3 over 6 raised to the second power equals 1. Okay, so you get an oval. Like that. Now, of course, if I put 6 back in the mix, it's circular, right? But you see how it gets like less and less circular as I change that? Now, where's my center? Where do you think the center is? Yeah, so still kind of the same thing. In fact, actually, I could label the point Let's go and label it. Okay. Get rid of that. Okay, cool. Now let's do this. How long is that?
6.
Okay. And how long is this? Okay, it's not a coincidence. They see 2 and 6, and you see 2 and 6 happening here. It's not a coincidence at all. The 2 belongs to X. 6 belongs to Y. So we use they're not radii or radius. Instead, we're actually going to call them axes. We're going to call one of them major and one of them minor. Which one do you think is major based on the way or in this case the Y or the pink? Which one's minor? The X or the green, right? Now they could switch. I could always make the major X and the minor Y. If I put a bigger number below X and a small number below Y. That's what could happen. Like for example, I could totally just do a little switcheroo. Make that 6 and make that 2. That's fine. You totally could do that. But now it goes 2 up and 2 down, 6 left, 6 right. Okay. We totally could do that. So that's something we need to be present to. Laura, good? Correct. Yes. Yes, exactly. And we're going to talk about the equation of ellipse very shortly, so you guys know what it is. And then from there, we could extract information about the ellipse. The derivation of it is crazy, but I want to show you because crazy is good. It's good to show crazy. But I'm not going to expect you guys to do a derivation on a test. Just, maybe I might make it an extra credit question. Maybe. We'll see. If you guys want that. Actually, that might be just a bad idea if you guys are looking for that. I'm okay with that. So anyhow, so this particular one, again, now we know what's going on. 4, 3. I go 2 left, 2 right. Well, okay, 2 left, 2 right, right? Then 1, 2, 3, 4, 5, 6. So there you go. And don't worry, you don't have to be an artist. It's okay if you are a little sloppy. So the equation is going to be, the general form is going to be this: x minus h squared over a squared plus y minus k squared over b squared equals 1. And that's going to be a, and that's going to be b. We're okay with that? Okay. And h comma k is right here. If it helps, a goes with x, b goes with y. Alphabetical order, right? That helps. A, we'll make a the horizontal to be the vertical. Now, some textbooks, just so you know, or if you work with tutors or anyone else, usually the a goes with the major, which we could do that if you want. I just want to keep things simple and say, look, and it's totally arbitrary. It doesn't really matter. I mean, plus M and N. I don't care. C and D. These are favorite letters. These are initials. Go for it. I don't care. All I care about is that goes with X. So it goes 2 left, 2 right. That goes with Y. Goes 6 up, 6 down. That's all I care about. The major axis is obviously the longer one. So for example, my major axis has a length of how long is my major axis here? 12. How long is my minor axis? Marie, go ahead. Yeah.
If we did like x minus 4 over 2, and then we said
And
that
C's.
a is 2, but
Mhm.
then like in the equation it's a squared, why would we go out like?
Oh, what I did, it's okay, it's all good. I do this, I do that every day. Well, what I decided to do is I decided to put the parentheses just around x minus h instead of the whole fraction. That's what I did. And the reason why I did that, you'll see when we get to a later problem, because we're gonna have to do completing the square with this. It's gonna be easier to separate this out from the parentheses. Is that what you're asking?
Yeah, so
Yeah.
then how does moving the parentheses to this?
So then that would just be a. So this would be just. It would just be that. But then when you distribute the square, it goes x minus 4 squared over a squared. Y minus 2 squared over b squared.
Okay,
Because remember with fractions and exponents. I know that's a true statement. So it's just a distribution of exponents. That's all that's happening. But it is going to be easier to think of like this. We have to complete the square eventually, because we're going to have to, the complete square is going to get a little bit messy, or no warning. It's going to get a little messy. So we'll do that in a moment. Vertices. The vertices are the endpoints of the major. The co-vertices are endpoints of the minor. So I'm labeling like that. I'm not going to actually put the coordinates because you guys can read the coordinates. I know you can do that. And the center, of course, is h comma k. We know that. Okay, so that's kind of dissecting the equation of an ellipse. H and K, and I'll give you the formulas. I'll give them to you. You'll know them as you know practice, but just as a sense of safety and just to kind of ease any anxiety about this, I'll give you the formulas. Actually, I'll do you guys even one better. Let's see here. Algebra 2 trig honors. Fall semester. I teach in the fall. Maybe here. Yeah, there we go. That's what I'm talking about.
Yes, yeah, that point. And you was the one.
So this is the formula I give. Actually, it looks like what I did do. Actually, I'm going to backtrack a little bit. Actually, I should backtrack. I did say A should go with X, B should go with Y. I did say that, didn't I? Okay. Let's revise that a little bit. A should be bigger than B. I take it back. A should be bigger than B. And here's the reason why. When we have to find the focus. So these actually that has 2 points to act as a focus. Plural, does anyone know what plural focus is? Oh yeah, look at you. It's an English language, but you don't say focuses. That's kind of weird. So C is gonna be the distance from the center to the focus. We're gonna talk about that in a few minutes. You're gonna need A to be bigger than B, because otherwise that'll be a negative value and be A squared minus B squared. So I take it back. We should let A always be the bigger number and B be the smaller number. That's okay. We had it the other way around in the graph. So I said A go with X, B go with Y. No, let's not do that. Let A be the bigger number. So in this case, if A squared equals X squared, that means it's opening longer horizontally. If A squared equals Y squared, it's opening longer vertically. Does that make sense? We're always gonna let A be bigger than B, just so you know. So yes, we will do that. Because I just realized that would make this too complicated on otherwise. So we have to keep this fixed as A squared minus B squared plus C squared. I'll explain that in a moment what's going on with that, because that's important. So let's come back to the notes. And I'll show you the derivation in a moment. Oh, Marie, go, yeah.
Like a wide ellipse or
Depends. Like, so for my case here, I should have done that. Because obviously it was opening. But honestly, it still doesn't matter in the grand scheme of things, because when you draw it, you just have to go with whatever number you see below Y. Like, oh, but A was this, I shouldn't know. This is just more to help us find what C is. C is going to be a new thing we're going to find, which is the distance from the vertex to the focus. Okay, and we're going to talk about that in just a bit. Before I do that, let's go through the derivation of ellipse. Okay, and you guys can sit back, relax. If your eyes are about to bulge out of your heads, I apologize, because this is a little crazy. So let's keep the center at 0, 0. We won't move the center from 0, 0. Let's have the major axis horizontal. So it's major along X, minor along Y. Now, what is the true definition of an ellipse? It's kind of a funky definition. What it truly is this. The grammar might be long here. The set of all points in which the sum of the distances from 2 fixed points is a constant. I know it's a lot there. So let's say you have 2 fixed points. Foci 1 or focus 1, focus 2. And foci is plural for focus. So focus 1, focus 2. And I'll call it negative C comma 0 and C comma 0. C is the distance from the center to the focus. Okay, we have a random point on the ellipse called X comma Y.
From the major axis, we'll call it a comma 0, negative a comma 0. For the minor axis, 0 comma b, 0 comma negative. Okay. Any questions of what is happening here first? Okay, that's what's happening. Okay. Now, the distance from here to focus 1, I'll call it D1. The distance from here to focus 2, I'll call it D2. So D1 plus D2 has to always be a constant. That's what that means. So if I were to pick another point somewhere else, to do the same 2 segments, those 2 segments will always add to the same number, regardless of where you are on the ellipse. So I'll let D1 be this and D2 be this. So if I use a little bit of distance formula, okay, fine, distance formula, here we go, this minus this, where we all that's found, and D2 is right there. So these 2 numbers have to be a constant all the time, okay? Those have to be a constant all the time.
Okay, so now what? What do I do? Right? Fine, it's a constant. What do you do? Well, I need another equation. I need another equation. So we could use a comma 0 as a point in which the sum of its distance from both foci is a constant. So what does that mean? What that means is that I'm gonna move x comma y
Over here. Okay, now be careful, this is a little tricky. If I measure the distance from here to here, let me mark that up.
Actually, maybe highlighter might be good. Yeah, let's go yellow. Okay. If I go from here to goodness. Okay, if I go from here to here, and I go, let's go to say green. From there to there.
How long, if I were to add a yellow to the green, how long would that be? Well, what would that be just like on the diagram? What would that be exactly the same as? The what, sorry? The major, yes, exactly. The yellow plus the green equals 2a. The yellow plus green equals 2a. If you think about it, this is almost the major axis yellow, right? This little portion here is represented by what? Green. So I move that green over here.
If I move that green over there, that's gonna be the whole major axis. So if you think about it, the length of the major axis is 2a, right? Because if I were to find distance from a comma 0 to negative c comma 0, a comma 0 to c comma 0, and do distance formula, I get 2a. Okay, now I got something I could work with. So now I can make this this deduction. Great. This root of that plus root of that equals 2a. This is where the algebra gets incredibly messy. So you have 2 radicals, move one of the radicals over, square both sides. But when you square the right side, you get another radical. So it just makes things even more complex. Do some canceling, isolate the radical again, square both sides again, FOIL again. I'm not gonna go through all the algebra, but as you go through all this, you stumble upon, what are those guys talking about? Oh, let's close the door. If you go through the whole thing and cancel everything out, you should get this.
You want getting this. We go through the entire derivation. Yeah, just trust me. It works. Trust me. It works. So this, I will give you this. I will not pass it, but I'll give that to you. This helps you relate A and B to C. C is the distance from the center to the focus. A is the distance from the center to the vertex. B is the distance from the center to the co-vertex. For A is half major axis, B is half minor axis. C squared equals A squared minus B squared.
This has nothing to do with Pythagorean theorem. It's just the way the algebra works out. And you can see I have all these funky terms like negative 2a squared cx and positive 2a squared. That's all crazy, right? Now, if we substitute for c squared back, I have to think back where I need to go back to. I think if I substitute back into here, if I substitute for c squared, wait one sec. Oh, wait, never mind. I'm losing my mind. Hold on. Shoot.
Okay, so this is just still this. This is just still crazy. Sorry. This didn't become this. We just know this. How do I know this? That's another derivation which I don't want to do. Sorry about that. Sorry about that. This is something we just have to assume to be true. This didn't become this. I lied when I said that. I don't know why I said that. That's crazy. This didn't become this. I know this, so I substitute for c squared to get this. Then I go through the entire calculation.
And once I'm all done, I get this. Yeah.
I get that. And that's going to be the equation of the ellipse. Of course, as the centers are 0, 0, you have a squared b squared. So just trust me, that's what happens. That's the derivation. Now, this is how you can deduce that c squared equals a squared minus b squared. I believe if you, yeah, d1, d2, so you have d1, d2 here again. And, oh, I got it. If you use 0, comma b and find the, those distances and add them up. And then do likewise for over here. And then set them equal to each other. Yes, you do get that. Yeah.
It's wacky. Just trust me, it works. You could go through if you at a later time. Let's get back to the notes again. Luke's good. Sure, yeah. I know it's kind of intense. So now let's actually go through the motions and graph this, right? I'll kind of do the first couple here with you guys. So what's my center for part A?
1, 2.
1, -2. And I'm sure I'm gonna do a better job of GP when I teach this stuff. So 1, -2. And then my I have to go now careful because the way it's written, B is 3, A is 5, because I didn't square the bottom. I had it, I have parentheses around the whole fraction. Because I have parentheses around the whole fraction, I'll say B is 3 and A is 5. So I have to go 3 left, 3 right. And 5 up, 5 down. Okay. There you go. When I asked for the key features, it's kind of a pain in the ass, but yeah, we should do it. What are the course my vertices? One comma, yeah, 1, -7, 1, 3. My co-vertices. Yes, -2, -2. And 4, -2. Okay, and then now I've already explained this to you, this whole c-square business. Should probably talk about it. That's going to be c squared equals 16, so c is 4. Technically it's plus or minus 4. So my foci, I'll use blue here, is me 4 away from the center. So that's going to be up 4, down 4. So 1, -6 and 1, 2. So if I picked a random point and drew these two segments, whatever those two segments add up to, has to be 2A exactly. Or if I pick another point like so over here, those two segments will always add up to the same number, which is 2A. Correct. Right. Okay. Okay, do likewise for part B. Do likewise for part B. I'll just do it on the board and we'll compare.
Oh.
Oh, and along the vertical, along the major.
Why?
So I don't like home.
Oh, sorry. Just take an Uber. Or Waymo. Actually, I saw Waymo in El Camino today. I actually wanted to cut it off to see if how it would react. I shouldn't do that. That's terrible. Yeah. Did not run him over. Oh. Huh. I will say it's probably gonna be safer than human drivers because we as humans suck as drivers.
And I've
But-
gotten into like 2 Uber car crashes already.
You have?
Yeah, horrible. Yeah,
Yeah, that's not good for your insurance. Were you at fault?
no, and like I was in an Uber,
Mm.
like it was.
Oh, I thought you driving. Oh,
No, I haven't.
well, your insurance will go through the roof if you're
Yeah.
yeah, because you're under 18. Okay, here's what I get for this one. My center's at 0, 1. Pretty obvious, gotta go 4 left, 4 right. So your vertex at plus minus 4 columns, you solid it that way. My coverse is 0, 0, 0, 2, so go 1 up, 1 down. The foci, c squared will be a squared minus b squared. So you subtract 2. And that should make sense because obviously it's gotta stay inside the ellipses. You want to add a squared to b squared, you subtract them. And you kind of want to do the bigger minus the smaller, right? So you get root 15, so you actually root 15 away, left and right. So that's how you graph an ellipse. Yeah, good.
Focus not being root plus or minus root 15 comma 1.
Oh, you're right. Good catch. See, I make mistakes. I'm human. I'm not perfect. Exactly. The Waymo would have got it right. I say I do worry about how it will impact the economy because a lot of people, that livelihood is being Uber or Lyft drivers. So I do worry about that. But we'll see in a few years what happens. Now you get your food delivered that way. All right.
Tesla's making autonomous cars too.
Yeah.
Driverless.
Yeah. So you can do your work while you're driving.
Yeah.
Can. Actually, I'd be more productive. All right, let's keep going, guys. Okay. So let's do this one next. This one should be pretty straightforward again. Let's not do all the labels. Let's do the graph because I think you guys understand the labels now. So actually, we are moving away from the origin. Okay, we are moving away from the origin. That's okay. We can handle that. I think you guys are ready to move away from the origin. So my center is going to be 1, negative 2. So that's pretty obvious, hopefully. And if I were to divide both sides by 36. Why did I divide both sides by 36? Yeah, that way you can figure out what's A and B. My A value will be 3. My B value will be 2. So this way you know whether to go, how far to go left, right, up, down. And you guys can determine the vertices and other stuff. I don't care. You guys now do that. Does that make sense? We're okay with that? Okay, go and try 5 also. So 5 is a problem where I would just give you some information and you have to write the equation, but you're probably best off doing a plot. So here's the deal. Where's the center for this, for number 5? Yeah. And where are the other points going to be? Yeah, just use symmetry, right? Okay, that's a crappy looking ellipse. Kind of looks like an eyelid. So my equation should be x minus 5 squared over, how far am I going left and right? Two left, two right, so you put 4 on the bottom. Y minus 1 squared. 1 up, 1 down. You get that. You go and try number 6 on your own. I'll put the answer up in a moment. Question on 4 and 5 are okay. How's this pace? Am I going too fast, too slow? We're okay, just right. All right. Yeah, well, go and try 6 and 7 actually. And then I do want to talk about completing the square. I'm gonna fast forward to like number 11, page 11. So we're gonna skip around a little bit. Yeah, go and try 7, 8. Sorry, 6, 7. Sure.
Away from the center. Yes, so in the center, it always goes.
In the center, yes, correct. Along the major axis. Correct. Let's see here. 1. Okay, hopefully you guys gained that. Yes, no, hopefully. I think. I could be wrong. Let me know. I was wrong earlier. Kaden corrected me. Right?
Wait, the focus.
Foci
Yeah.
or foci. Tomato, tomato.
On.
Yes. Yes.
Yeah.
Otherwise, we'll be outside the ellipse. Okay. We're okay? Can we move on? All right. Yes, let's fast forward to page 11. Because I already kind of explained the whole concept of an ellipse when I showed my derivation. This is like a demonstration you can do with string. I don't want to do that. I don't care for that. We'll just skip page 9. Page 10 is like the anatomy of an ellipse, which I already talked about. I already talked about that with you guys. So we know what's going on there. There's a word problem. We'll skip that. Let's jump to this page here, page 11. And let's talk about completing square. And this is completing square on steroids. Okay. So look here. Actually, not quite on steroids. That's close. It does get you can make this even more challenging. So here's what I'm gonna do. I'm gonna group the x's like this. I'm gonna group the y's like this. And push 11 out to the other side. So I'm just doing a little rearrangement, not a big deal. Right? What do you think we're gonna do next? What do you guys think? Yeah, don't do 9x, just a 9. Just a 9. and leave a little room for a constant inside the parentheses. Take out the 4. Leave a little bit of room for a constant. Okay. What is half of -2 squared? Half of 4 then squared. And squared. Sorry. 4. No. You're supposed to do 2 things. That's my bad. Half then squared. Sorry. Half then squared. But what do you add to the side? I'm gonna add 1 and 4. Is that proper? Nope. Yeah, what did I truly introduce to the left side? I truly introduced 9 and 16. Right? Because if I put you need to guarantee that if I go backwards, I get to my original equation. So I really introduced a 9 here, just 9 on the outside. Really introduced 16 here. Does that make sense? Why I put 9 and 16? And I will promise you, I'll make sure these numbers work out nice and clean. Because always, that's why I work them out first. Because if it was like 37 or 38, that'd be just cruel. And then divide by 36. So what I've just done is I've done a process that you guys learned last year in Algebra Trig Honors, where I can now extract all the useful information I can about this ellipse. I know my center. I know how far to go left and right, and how far to go up and down. I'll be able to determine the foci after that as well. So graphing it, I know you guys can graph it now. I'm not too worried about that. I mean, if you want to graph, go for it. Actually, we'll do it really quickly. Just need some space here. So 1, -2. 2 left. 3 up, 3 down. Graph a scale like crap. Totally. That's not how I'd scale, but whatever. It's fine. Just go with it. Yeah, I know you guys can turn all the other stuff. I'm not worried about that. But when we do the foci, you're always gonna add it to whatever coordinate stays fixed on the major axis. So actually, let me do the foci because that might be important. Your C value is gonna be √5. Do you see why C is √5? A squared minus B squared equals C squared, right? So if you think about it, I have to go √5 up and √5 down. So X stays fixed, Y does not. So you write your foci, you write it like that, just so you know. -2 plus √5, -2 minus √5, because you're going √5 up, √5 down. Okay. So it'll be over here and here. Okay. So go ahead and do the same thing for number 7. Try to do the same thing. It's completing a square.
Must be like a little bit wide.
For the one that drew, yeah, that's just because the scale's off. Yeah. And do 8 as well while you're at it. The problems on the next page are kind of repetitive. So we could probably maybe just do some word problems after. Or if you want, I could show you some crazy problems. Crazy is always good.
This be on the test.
Oh, yeah. Well, I get crazy. I talk to anybody who's having problems with Trig Honors. I get or this class.
The axis, it's just how we said.
But yes, half, right.
That's 12 different songs. I've actually been in radio. I don't know, I still don't know if that works. Everybody is the right system. How much of it that we got? Minus 12 equals 6. Which is 2. So C is 2. So bigger value, so it's the one that there is.
Okay,
Like a big square here, work it out. Not super nice, get root 12, that's okay, root 12 is like 3 point something, put 3 point something away out there. I do care, but you don't have to be precise. 6 up, 6 down. The other one, just do a quick sketch of your first, oh,
crap. Okay, it's good. I'm glad I did this. What did I do wrong in the rate, guys? What did I do wrong? Yeah, not co-vertices. I treated this problem as if it were co-vertices. I would have been 100% correct. It was co-vertices for number 8. I got number 7 right. I know that. I think so. Okay, it's okay. I will fix this. So my drawing was not correct. So 0, 0 and 4, 0. Now the foci is always on the major axis. So that means I have to go. So my center is at 2, 0. Let's switch colors. I'm glad I caught that. Okay, oof, so much better now. So now I could do this. My C is 2, my A is 4. C squared equals A squared minus B squared. 4 equals 16 minus B squared. B squared is 12.
Wait, why is 8 and 4?
Don't want state to be over. That's why. I'm good, guys. I'm all good. I'm good. Thanks, Sophia. I appreciate it. Good looking out. Okay. Okay, so let's, you know, I need to slow down. Okay, my set, my foci here, right? So where's my center? At 2, 0. Then I need to go 8 away to get that. So now c squared equals a squared minus b squared. 4 equals 64 minus b squared. B squared is 60.
How do you know you?
The major axis is 16. Half of 16 is 8.
So the sensor
Yeah.
is always like between. the
Of
two.
course, yeah, right. So the ellipse looks kind of funny. It's almost circular. That's so ugly. It's okay. So then your equation is going to be x minus 2 squared over 64 plus y squared equals 1. No. Mm-mm. But why would you go 6 up, 6 down? I don't know for number 8. No, because when you solve for b, you get root 60. Yes, because remember c squared. Oh yeah, because you made the same mistake I did. I thought a was 4. A was 8. You made the same mistake I did. That's why. Okay,
That's in 2 weeks.
I haven't decided yet. How's the Niners win tonight? I'll push a test out so late. They're injured like crazy though. And they're on the road. The Rams are pretty good. Let's see what happens. See about Giants are on the playoffs. That'd been fun. It's always fun when they're in the playoffs. Let me just show you some crazy problems, and then we'll end for today. Show you how crazy looks. We'll practice crazy next week. Hold on. Just so you guys want to take a stab is what happens here. But yeah, for the most part, we covered ellipses, so I think we're okay. So get crazy. Uh, That's kind of cool one. Okay. What do you guys think about this one? So how do I go about solving that? The distance between the two foci is 72 feet. So 2c okay, the sum of the major and minor axes is 216. Okay. Or a plus b equals 108. And we know this, right?
Oh.
And you could do,
A plus B and minus B.
or you could say this. So of course I kind of guide you through the process, but yeah, if you could do that and then you can solve for p afterwards. But like that's the kind of problems that I would probably come up with for a test, and I'll get creative. I always somehow just think of something new or fun. But we're gonna practice this. So you see, it's really more knowing the skills I've given you right? You guys knew, oh yeah, C is 36. Okay, yeah, A plus B is 108. Oh yeah, I know this other relationship. And then you make that connection like, okay, now I can substitute. That's good problem solving skills, right? That's think outside the box a little bit. This one's you guys can't handle that one yet because we haven't done hyperbolas, but let's try see if I can find another one here. By the way, and I taught this class with your mom, so you can ask her for. She always said, Mr. Yu is crazy. He wrote all those crazy problems. No, it's hyperbola. Oh, this is a fun one. See this one here. This is a cool one. So this is real life. The gateway arch. So what you want to do is you want to model it like this. You deliberately make that monument or a structure a parabola facing down. Here's the vertex. You told the focus, the height of the arch, sorry, is 16 times between the vertex and the focus. So let's say the focus is here. Here's the vertex, of course. And that's P. From there to there. Isn't that height supposed to be 16P? Because they said so, right? They said so. Okay. And 630 feet wide. So what would I do for my x coordinates on the x-axis here? Yep. So what would be the coordinates here? Comma negative 16P. And then don't we have an equation for this? X squared equals 4PY. 315 squared equals and you have to deliberately put a negative out because it is going down. Negative 4P. And then you can solve for P. Once you solve for P, then you get the height. And by the way, the height's exactly 630. Kind of interesting structure. The width and height are the same. So these are kind of questions. Just want to kind of introduce you to this kind of thinking. I will find other stuff. But it's stuff will get a little creative. So anyway, that's the kind of stuff that, so I want to expose you to these test style questions early and often, so you guys know what to expect. Okay, I think we're all done. I will give you guys the homework I'll post to Schoology. It'll be the same packet, some basic stuff on ellipsis, some stuff where ellipses move around a little bit. I might throw a word problem here or there. Yeah, so I think we're good for today.